Good morning, guys. Welcome to another Python fundamentals lesson. We're continuing with our recursion um, exercises, and our first task for today is to create a recursive function that calculates the factorial of a number, right? If you remember from the slides, the factorial was of the form this multiplied by this multiplied by this up to you got one. Mistaken. Good. So we are going to create that in Python using a factorial, using a recursive function. But first, before we do that, I would like to just create a function to calculate that without the factorial, right? So as you can see, we have a sequence going on right here. I have n, then I decrease n, then I decrease n again. So then I decrease the previous value by one, then I continue until I get one, right? So I am going to create, and if this isn't clear for someone, so if I say the factorial of 5, I am saying 5 multiplied by 4, multiplied by 3, multiplied by 2, multiplied by 1. And remember that lovely mathematicians have defined the 0 factorial to be 1 and not 0, because from multiplication tables, we all know that any number multiplied by 0 is 0, but fortunately, they defined 0 factorial to be equals to 1, okay? So let's go from there. All right. Now we're going to have, what do we want to do here? I'm going to define a function called factorial loop, and it's going to take in a number, right? And it's going to return a result. Okay. So let's just first get our case, this case over here. And if the number is equals to 0, right? If the user puts 0, it should just return 1. All right. Now that that's out of the way, return 1, or I actually want there to be just one return variable. Right now I haven't, so I could say result is equals to 1, and then just return the results. All right. The other way could have worked, but I think I like this one better. The other way works, not would have, works, right? I just like the look of this, just one return variable, right? And then what from there, we now have to generate a sequence of numbers. And I want to use a for loop. So for num, and remember the range function, and I want to start at 1. I'm going to say 1 n plus 1. Now the reason why I say n plus 1, right? Remember the range function, this value is not inclusive, right? Is not inclusive. So if I was to say 1, 2, whatever the value that the user inputted, it would go actually to n minus 1, right? And it wouldn't include n. Okay. So now that we've verified that, or let me just show you before I continue what I mean. Print range 1, 2, 5. And I'm gonna say where we Python recursion. Okay, yeah. Now what I wanted, I could just do that and see if that works. Sequence of numbers. And as you can see, so I just created a list on the fly, right? So 1, 2, 3, 4, right? So it doesn't include 5. Okay, range is a type, more data structure. And so now you see what I mean. All right, so if I want it to include 5, then I should go to 6. And if we run that again, I will see 5. All right, cool. Just bear that in mind when you're using the range. So from there, what do I want to do? I want to first define a value, a variable that I'm going to iterate over. All right, and I set it to 1. All right, so the result is 1. And then as I loop through these values, I am going to increment. I don't think that's how you spell result. Okay. All right, I'm going to increment this value by the number, right? So that's how you do that. It's a shortcut in Python. I think I've shown you this before, but if I haven't, result means that's just shorthand for result, right? By num, right? Just gonna keep on doing that. Okay. So that is that. Okay. And then I'm going to return results. So essentially what that's going to do, it's going to say 1 times 2 is 2, 2 times, and then store it in results. Then I'm going to say 2 times 3 is 6, and it's going to store it in results. 3 times 4 is 6 times 4 is 24. 24 times 5 is 120, if I'm not mistaken. All right, cool. Yeah. So that is the function that I want to create. And if we test it, okay, we're going to say factorial loop. We're just going to do 3. So that's quite quick. And I'm going to print that so that we can see it down there. Then remember, this should be 3 times 2 times 1. And that 3 times 2 is 6. 6 times 1 is 1. I mean 6. All right, cool. Now we print that, we see that 6. All right, we go to 4, I should get 24. Let's go to 5, I should get 120. Let's go to 6, 6 times 120 is 720, right? We should get 720. There we go. And what happens if I get, if I get a negative number? I didn't really think about that. This might fail. Yeah, okay. Mm. Okay, we'll put a check on that. But anyway, it's working for now on the positive side of the number line, all right, which is what I'm just interested in right now. Okay, just to show you that. And then if you want to improve that, you can do it for all numbers. Okay. Okay. So what you could do, come to think of it, if you had to put it on the number line, and since it has to be, if you had to say -5, where would you be counting from? It has to be 5, 4, 3, 2, 1. All right. It's the same thing as 1, 2, 3, 4, 5. Anyway, so now let's get back to the actual point of this video, and which is to actually do this recursively. So you can see that it took me so this function is 7 lines. All right. It could have been shorter if I just said result is equal to 1. I wonder if you could do that. You can't do that. Okay. Cool. So now how do we do that? So I'm going to say define rec factorial, and it's going to take in a number, and it's going to say if, just like before, n is equals to 0. This time I'm just going to say return 1. There are no variables that I'm creating for sake of sake. Return n multiplied by, I'm going to call our function again, rec factorial. It's going to be n minus 1. Okay. And that's in 1, 2, 3. 3 lines. Okay. 1, 2, 1, 2, 3, 4. 4 lines. Okay. So now I'm just going to say print factorial. Actually, let's just do that. Print factorial rec factorial and 6. And we should see the same results if I'm not mistaken. 720, great. And if we're to go up to 10, this might, right? So it gets to see how big it gets. I'm not the limits where Python will take us. Let's see. Okay. And it's getting bigger and bigger, and it passes, say, hopefully it doesn't 120. That's a large number. Let me just go 50, 150. Also quite large, but still. Let's see if Python will complain. It will take it. They didn't. All right, so there we go. That is quite a large number. So now let me just like before, I drew a tracing tree for you just to show you how the recursive function was working. So I'll see you there just now. Okay. Yes, guys. Yes. So let's welcome to the Jamboard. And let's try and draw this tracing tree for this function. I hope you can see I'm using another device to do this. So hopefully might be some lag. Right. So we call the function, I'm just going to use a simple number like we did before, which is 3. And then I'm going to say rec and f factorial. And I'm going to put in 3, right? And then what happens is I call the function and I return a value called 3. Not called 3, but I return 3 because this is the function, right? It's not 0. And then I have to now, and I multiply that, and then I call the function again by rec factorial, and I say, what's 3 minus 1 is 2, right? And then here, like before, I return 2, and then multiply that by rec factorial. Ooh, you can see it's not it is not. Just give me 2 seconds. Okay, we're having some technical difficulties. The device is not syncing with, so you can't see it. But so this will be rec factorial 3, we get 3, rec factorial 2, we get 2. Then we multiply by rec factorial 1, right? Fortunately, I've done this before. We get rec factorial 1, right? And then from there we move down and we get rec factorial 2, meaning 0. And remember, if n is equal to 0, return 1, so we return 1. And then we now, just like before, we have to finish up all the instructions, which is to multiply the results of all those. So it's 1 multiplied by 1, multiplied by 2, multiplied by 3, which is going to be 6. Actually, yeah, it's 6, right? So that's how you get the factorial. So that is a factorial, and that's the tracing tree for the exercise. If you have any other way that you did, let me know. And cool, see you guys when we're doing the Fibonacci. Cheers.